All right, it's looking like it's time. Let me check the levels and everything. Good. Perfect. And I got my, I'll go ahead and restart the Twitch chat because for some reason it didn't display that first message in the chat. All right, cool. So welcome back. We're working on the game engine. Right now, I'm tracking down a little bug that might be kind of a problem. But I'll do a quick overview of where we're at, where we're going. So I'm opening up a quick scene like this. So over the last week or so, we've been doing an overhaul of the way we do materials, starting with the way we do textures. We've done a lot of design work. A huge portion of these last couple of streams were just spent figuring out what would be the best user experience, as opposed to what would be what we need to code. What we spent most of yesterday doing was making the inspector work with content in the content browser. So you might be familiar with these kinds of workflows with Unity. You select the files, and we added file selection as well. You select the files, and then you can edit the import settings inside of the inspector. In our case, we're not doing that directly. Unity has a similar system where they have metadata files .meta adjacent to the raw asset file, and so every raw asset you treat it like it's the thing that you're setting metadata on it, but it's actually being saved inside of a hidden file that doesn't even appear inside of the folder. I'm doing a slightly different tack. I'm making a clear division between an enterprise asset and a raw asset. So you have PNG files, which if you double click and open them, you have your actual images for your textures. Then you have the EP text files, which are going to be YAML based files that you can commit to your game code. You commit the PNGs as well, but the idea is that it's a YAML file that contains the settings that you actually care about. And so to make these changes, we implemented the inspector's API for registering component callbacks, asset callbacks. So that way you can, similar to how you can register an inspector field for a custom game system inside of the inspector, when you're selecting an entity, you can select a asset in the content browser, and then it'll be able to take over the inspector. So here it says, I am an image inspector, license and registration, please. That's because we have registered an inspector for the EP text extension. So whenever we have a selection that contains only .ep text files, it will appear in here, and we'll work on the GUI of that today, and so we can actually start doing things like selecting the texture asset, changing its min and map filter modes and clamping and things like that, and then those can be used directly inside of the renderer if we want. We'll move from there to a material system, but textures have to be done first because they are key to they're a core component, a core input of material shaders. But we'll get there. Yeah, it's a kind of a work in progress. Now I'm dealing with a strange bug related to one of our refactors that we did recently to make this work. In order to make it possible to edit the textures live, I had to separate the loading code, the code that actually takes and reads the file and submits the data to OpenGL, and the code for setting its properties. So that way you can change the properties on the fly without having to reallocate and resubmit the texture. However, I've identified that if I go to quit the program under certain circumstances, we will have a issue where I think I can do that without even opening up a scene file. Yeah, we have a condition where we're trying to bind an invalid texture target for a texture before we go to clear it. And that's what I'm going to deal with real quick. So the core of it is, if we take a look at the debug console, we have an OpenGL error, a GL invalid enum. And that's occurring because if we inspect the maps that we're getting the target from, we have an index of 0 going into texture and slot, so we're looking at whatever texture slot's in slot 0. That does have, if we look at the texture and slot, we do have a texture ID 1 in slot 0. And when we look up the target type of texture 1, it says that the target type is 0. And that tells me that it didn't actually exist inside of target type of texture until we use the lookup key here. It's a little hard to wrap my mind around, unfortunately. But this code normally is safe. That is when you use a square brace operator to get elements out of an STD map, that will insert the element if it doesn't already exist, and I think that's why we're getting a 0 value for this texture. But the bottom line is that target type of texture should always have a value for every texture that's currently loaded. And so somehow or other, there's a discrepancy where it doesn't contain every target type that we are looking for. So interestingly, sampler type needed for texture, this is the map that we've used for tracking all this before, it does show 1, 2, 3, 4 textures, texture ID 1, 2, 3, and 4. So we know that there are 4 different textures loaded at least. Hang on, that might be part of the problem. I'm thinking this through, because at this point we haven't opened a scene yet. So at what point are we binding textures? Let's break. I think I can reliably reproduce this issue by simply quitting as soon as click and close project as soon as I same difference. As soon as I open it. So we have the project open, we don't have a scene open. We shouldn't be loading textures yet. Let me, let's go to the load texture call. Here we go. And I'm just going to set a breakpoint on it. And when we go to launch, I'm going to track each call to it. There's not a single call to it. That is interesting. So we haven't loaded a single texture because we haven't launched the game. We bypass the API for the sake of loading the icons in the content browser. But if we're not calling load texture, then you would think sampler type needed for texture wouldn't be populated. Let's pause. And I want to see what these... Oh, I don't have them in scope in this. Let me find a place to break and we can do an examination. I keep hitting Control P instead of Control F. So there's bind, that's GL bind texture. Let's look for the bind texture API call. Here we go. Here it is. And I guess I'll set a breakpoint. Okay, bind texture is not being called at all. And I guess that makes sense because we don't have anything open yet. So how on earth is current slot of texture? How are these getting populated? I need to find a point to break so that I can see them. If it's not in bind texture, I guess it would be in pre-draw. Let's do pre-draw. Okay, here we go. So pre-draw textures, this is invoked immediately before the enterprise draw call, which is not the same thing as a OpenGL draw call. It's just the call that happens once per frame to draw everything. And then I'm going to take and inspect what we've got in here. So for starters, we do have 1, 2, 3, 4. We do have 4 sampler type needed for texture registrations. This suggests that we have created texture IDs 1, 2, 3, and 4. However, I don't think that that's correct, because we haven't even gotten a call off to load texture. Oh, hang on. Did we get a call off to load font? Maybe that's the thing. Maybe that's the trick. Let's go to testgame.cpp. This is where we set things up. So we start by registering controller wake events, so we can do gamepads if we want. We then push the test state, and then we load the scene file. Oh wait, this is the game init. We don't even do that. We don't even do that in editor. So in sysinit we call render2d.init. I don't believe that does anything with textures. Yeah, we don't even include the texture header, so the issue can't be coming from here. In editor play cleanup, we do a hang on, editor play init, we do a push state, and this might allocate something. Game init, I don't really see anything here that could be going off. It's awfully confusing. I would have expected this entire list to be completely empty. Let's do... Wait, that's the wrong file. I'm going to look up every place where we modify these lists, or where we access them with square braces. I'm thinking that perhaps these are getting populated with square braces in places where we're just trying to read the values. It's not really clear to me. So we'll do the search for OGL target type of texture and the square brace, and all of the mentions are inside of textures.cpp. Now we know from looking at the debugger that the values that are going inside of target type of texture appear to be texture 2D. 3553 is the decimal form of the GL texture 2D constant. I know that off the top of my head because I've been looking at this code recently. Normally you'd have to look that up inside of your headers. So that suggests that it's being populated with an actual texture value. So looking at these searches, there's this code here. This is the place where we determine whether it's a 1D or 2D texture from the other. And this kind of is tried and true code at this point, because even though the line target type of texture is new, we were always doing OGL sampler type needed for texture assignment here. Okay. And then here we do the OGL target type of texture bind. However, let me look at this. This is where we do the assignment. It's an if-else, so no matter how you slice it, this key should exist at this point. We don't have any breaks or returns between there and here, so this should be a valid value. I will continue on. We do the comparison. This comparison here is just to determine whether to use GL text image 1D or 2D. And then after that, the next calls are in set texture properties. Maybe this is where the problem is, because set texture properties is a new function. We split it off from the loading code in order to make all this work, to make the editor inspectable. Current slot of texture. Okay, current slot of texture I'll have to keep an eye on too. It seems to think that we've got 0, 1, 2, 3, and 4. Well, 0 is always in use, I think, but it seems to think that we've gotten 1, 2, 3, and 4 in use. That seems wrong. 0 is the null texture. Okay. So here we're assigning the slot of the texture. Let me... I'm gonna start a list. I'm nothing if not consistent with my use of lists. So I'm gonna make a list of things that we need to worry about. There's the OGL target type of texture. There's the OGL sampler type needed for texture. OGL current slot of texture. These are all maps associating the texture handle to a piece of data. So these should all have... Think about it. These should all only have keys for active textures. So that means that when we go to delete a texture, we get rid of the appropriate key. The current slot texture is somehow getting a bunch of values in it that I think before what I was doing is I was planning on keeping this as a persistent list. So whenever you bound a texture, the texture ID would show a -1 when it's not in use and a number when it is. However, I think my thinking on that has changed, especially now that we've got an editor going. We probably want to do a key check to see whether or not we have a slot assignment. And if we do, then we use it. I'll come back to that idea later. When we go to clean up, we use this. Okay, so here's my thinking now. I'm thinking that it would be probably easier, now that I've got 3 data points that I have to associate to the texture IDs. Let me take another look at this. Yeah, path of well, there's also path of texture handle, but I don't think that counts. I'm thinking perhaps I should do this a little more intelligently and do, instead of a bunch of maps associating the texture handle with a piece of data, to do a structure containing all of the data for each texture, and then associate the key with that structure. The lookup time should be equivalent. However, the main benefit would be that it's a lot easier to keep track of what's changing. It also makes it a little bit more extensible too. We can easily add elements to the structure, but then not have to worry about it being cleaned up everywhere. Okay, yeah. So in typical fashion, I start off with a goal, and then I completely sidestep immediately to do a refactor, but I think that's going to be necessary for resolving this bug. And it may even help out with the end goal as well, because we're going to be needing to easily modify properties of the textures and store the properties that we change. So yeah, let's close out of all this, and then we will make a few changes. So for starters, I'm going to find each place where I have utilized the OGL target type of texture, where I've newly utilized it, and I will revert it to its previous code. So that way we're not dealing with OpenGL errors anymore. And also because I can compare what I've done against tried and true code. So that includes this section down here. Previously, instead of looking up what kind of texture target the texture needed, I looked up what kind of sampler it used and then deduced what the target type was. And I got rid of that because it's a lot more code. So I just cached the target type needed instead. I'm going to go ahead and undo that change. And then do the same thing here, where we got the blind target deduced from the sampler type needed for that texture. Okay. Okay, and then everywhere else is basically the same. Okay. All right. So let's take a look at this. For starters, where's the definition? Well, I guess the definition is in OpenGL.cpp. These are OGL details. So these are the three maps in question. If I take a look back at textures.cpp, it does have a couple of its own, but I think I'm going to treat them as separate. So we have an association between the texture handle and the hash of its path, and that's I'm trying to remember what I use that for. So we have a lookup function for getting the texture hash path. And then we had reference counting by the hash of the texture path. Okay, so that's the main perk of keeping that around. I'm thinking that maybe I could associate some of these static ones. So dimensions of texture, for example, associate that in a STD map structure. So the key is texture handle, and then the value is a structure containing all this data. Yeah, however, I don't really have too much of that right now. It's just these two values. 3 if you break the X and Y into their own values. Okay. Yeah, so I'll leave this as it is, though I will bring this down to better organize. So in OpenGL.cpp then, these three maps I'm going to make into their own thing. So I'll go to OpenGL.h, go to the declarations, associating here we go. Associating the texture handles with a bunch of things. So I'm going to do a struct. The struct will be called texture metadata, I guess. Is metadata one word? I think it's 2 words, but I'm not entirely clear. One word. And inside we will put a GL int for the current slot. We will put a GL enum for the target type. And then we will do, wait, what am I doing? These are semicolons, not colons. And then we do a sampler, a GL int sampler type. Is sampler type actually a GL int? That's interesting. I feel like that should be a GL enum. Let me take a look at that. Oh, that's by setting uniforms, that's right. Now I'm thinking about it. So yeah, that would be in int, I believe, because it's GL uniform. Yeah, the location for the uniform is a GL int. Okay, that makes sense. Okay. GL int sampler, but it's not the sampler type, is it? Alright, getting a little confused. Yeah, so we use the macro to get the hard-coded constant. GL sampler 2D. I guess the main use of tracking the sampler type, it comes to not the textures.cpp, but the use in shaders.cpp. Well, at least that's what makes sense to me. Huh. It's used in frame buffers. So you gotta create a frame buffer, and frame buffers. Hang on, frame buffers would be why I have tracking for... Okay, things are starting to make a little bit more sense now. In the game view and in the scene view in the editor, we use the Enterprise API to create textures. So when we use the create frame buffer API, okay, I think I'm starting to piece together what's gone wrong with that bug. And if I can resolve this without having to make all these changes, then I'd prefer to do that. So I've set a breakpoint on the create frame buffer call. We're going to run the enterprise again, and we're going to count how many times it calls it. I would have expected 2 calls because the we only have 2 places where we do a frame buffer, but there are 4 textures listed inside of the structures. Okay, create frame buffer. We've got 1 call so far. So far, we don't have any metadata stored for any of these. All of the sampler slots are considered empty. The size of target type of texture is 0, and sampler type needed for texture is 0 as well. I hit continue, and now sampler type needed for texture. Okay. This is where we were getting turned around. Okay, let me think about this. So, yeah, I guess I just didn't track down all the places where I needed to populate target type of texture. However, this identifying that the issue arises from the call to create frame buffer on the editor side makes me wonder whether or not I should split off the implementation from this function as well. In the case of textures, we're bypassing reference counting and texture slot assignment stuff when we go to create a texture using the implementation function. So that way it's not unloaded when the game project is, and we don't have to recreate it. It's kind of looking to me like we're doing the whole shebang with the frame buffers with reference counting. Okay, I'm gonna hit continue and see if we hit on this again. We don't. We get to pre-draw textures. But by the time we get to pre-draw textures, we already have 2 more samplers listed. However, those 2 more samplers do have an associated target type of texture. So these 2. Okay, so here's what I'm thinking. Textures 1 and 2 are the frame buffers, and the textures 3 and 4, or the frame buffer attachments, I should say. And then textures 3 and 4 are the file and folder icons. And those should only be loading in the implementation file, or an implementation function. Oops. In here. So I guess somewhere in here we are. Aha, okay. Alright, this is making sense. So this whole target type of texture thing, this code is going to be going soon anyway. This code is working correctly. It's associating the texture IDs 3 and 4 with these sampler texture ID types. And that's going to cause no conflicts because these are OpenGL texture IDs and they will always be unique. So as long as I don't delete the folder and file icon textures, then this data will not be used incorrectly by the engine layer. However, we're going to be replacing that soon anyway, so it's going to be bypassing everything. The key with the first bug that I'm coming across is the fact that frame buffers has the ability to create textures as well, and I forgot to have it set the target type of texture member as well as the sampler type needed. So let's look for all these cases where we do sampler type needed for texture, and we will do texture target type of texture as well, and we'll set that to be GL texture 2D for this guy, and then the same for here. And then the same for here. Okay. So if it's a depth only format, we do texture 2D, sampler 2D, texture 2D, sampler 2D. These are all going to be texture and sampler 2D anyway. So I guess I could probably just put that up above, but whatever, I'll leave it as it is. I'll just insert the things that we're missing. When it comes to render buffers, that's okay. Render buffers are not things that you can rebind. They are obfuscated. All right, so I think this is probably what we need. I'm gonna stop debugging, gonna rebuild, and I'm willing to bet that it won't crash anymore. And if it doesn't, then we can move on to the task that we actually care about. Any minute now. Okay, F5. Good, and now if we go to close the project, sweet. And no OpenGL error either. So we'll open up the test game project again, loaded up the DLL, and we can open up a scene file, and everything seems to be working. Let's go to the pre-draw call in textures and set a breakpoint. And if we inspect these structures, they are all correct looking now. They have data for too many texture IDs, I think, because we don't want textures 1 and 2 in here. We're not interested in tracking the sampler and target type for the frame buffer textures. At least we don't care about them in the context of the editor. But for now, I'll leave them. We have 1, 2, 3, 4, 5 other texture handles. So 3 of them would be the sprites inside of the scene, and the other 2 would be the file and folder icons. And once we get the inspector working and we're actually editing the metadata directly from the editor, that will move the code that sets these values up outside of that function, and so they will not be populating the stuff that we load for the use in the editor. Cool. I think we're back on track. Awesome. So close out all this, and then throw up all for the VS Code pet. There you go. And now we'll work on the texture inspector. So it would be inside of this file. Let me close the others. Inside this file, we've got on texture inspector GUI. This is the one. We currently just have it saying this line of text. We can now have the GUI do a whole bunch of other things as well. Oh, but you know what? There's one more thing we need to worry about. When we receive this call, this call will occur every single frame where the inspector GUI is is displayed. Close out these couple of things. However, we don't want to be hitting the file system every frame. So the strategy here is that when the selection changes and we've got multiple files selected with the texture asset extension, we will, at that time, that one frame, load all the data from all those files. And then we can start editing them within RAM, applying them only when we switch away or we click an apply button. So that's the purpose of this Boolean selection changed. Selection changed is not implemented yet, so we'll need to start with that. So we get whenever we change what we selected inside of the content browser, we'll be notified inside of on Texture Inspector Gui, so that we know that we actually have to hit the file system again and refresh what we're looking at. So for that, we'll go to editor.cpp. This is all the public-facing editor interaction stuff. And then when we go to register file inspector, that's this stuff. We register the inspection, yeah, that's right. And then inside of it would be the inspector.cpp. This is where we actually do the implementation for it. So this block here, stop it. This block here is for the entity selection, and this block here is for the files. And we kind of hacked this together at the end of the last stream, didn't we? So it probably would be worth making this a little bit better. The selected files come in as strings, so we need to actually parse out the extension and then look up confirm that they all match, and so on and so forth. All right. So if there are selected files, we have a set of extensions. I'm going to change some of this a little bit. I'll use a set of extensions still, because we want to be able to display which extensions we have selected in the case of a multi-selection in the inspector. All matching equals true seems redundant, because if they're all matching, then we would only have one extension inside of the set. So yeah, let me comment that out. And next thing we do is we iterate through the selected file paths. So we need to get the extensions. So first thing we do is we look for the dot. We also need to confirm that the dot follows the last slash character. Because otherwise you might have a dot in a folder name somewhere higher up in the path than the file. So we do path.rfind for the dot. Is there an rfind first of? I guess not. Because we need to check for two other characters. Let me look this up real quick. I think there's a reverse find. First of. If there's not, there should be. Even if these algorithms are really simple to write, I prefer to just have a function named what it does and not have to make my code look a little bit more confusing if I don't have to. There's a find first of, which I'm very familiar with. But our find first of finds the last sequence of elements in a certain range. What's this? Searches for the last occurrence of the sequence. Okay, so that's a sequence search. Okay, that's a little annoying, but oh, find last of. That's what it's called. That makes a lot of sense. Find last of. So it'll look for all the characters in the string. Okay. So what we do then is we'll say pause equals path dot. I don't know why I didn't think find last of was the opposite of find first of. I just didn't. So find last of. We pass in the characters that we wanted to look for. We're looking for dots, slashes, and backslashes. Because these strings could be coming in as absolute paths. Wait, can they be coming in as absolute paths? Let me think about that. No, we should enforce forward slashes on these paths. And they should always be relevant to a virtual drive. Yeah, okay. So it has to be a dot or forward slash. That makes sense. And then we don't pass in an offset because we're starting at the end of these strings. However, I do need to go back in and make sure that the selected files in the content browser, content CPP, I need to actually make sure that they are guaranteed forward slashes. Okay, so path as string comes from path.u8 string. That can contain backslashes on Windows, so we do nsd replace path as string dot begin path as string dot end, and then plus path. Wait, that's not right. Old value, new value is what we need. So the old value would be backslash, and the new value is forward slash. And then I'll need that in a couple of other places here, I think. Yes, we do an insert path as string, so that's already pre-formatted. Then we have selected files, .insert, range selected first. Okay. So we do an insert into the set from the iterator.u8 string. That's a little tough. Oh, you know what? These are. It's actually not just important for us to get the forward slashes. We are getting these as absolute paths, aren't we? Hang on a moment. Yeah. So these paths need to be converted. It's I don't know why I didn't think to do this before. But in file we have the native path to virtual path. I guess I don't have the header in here yet. Oh no, I do. It's here. So yeah, native path to virtual. So what's up with what's up with this? I have to say EP file, that's right. Okay, so we get the path, convert to a U8 string, we pass that into native path to virtual, and then that goes through the trouble of converting it. Going and replacing these slashes, and then replacing the drive letters with the things and stuff. Yeah. Back. All right. So path as string is going to be a virtual path, which is critical for the sake of the file system. Because when you're writing an inspector, you want that to be portable code. You want to be working in virtual files instead of in platform specific paths. Okay, select files.clear.insert. Okay, and then when we go to insert the first .u8 string, we need to do the same thing here. EP file native path to virtual. Oops, and we'll wrap that whole thing. Okay, doing good. And then the same thing here. We need to do EP file native path to virtual and wrap the U8 string that comes out of the iterator. And then here, path as string is already converted into a virtual path. To make this a little bit more clear, I'm going to say path as virtual because we have a variable here, path, that's an std path, and that's going to be canonical dependent upon the file system. Native path to virtual will give us the virtual version of that path. It makes sense to say path as virtual. So that way when we're looking at the variable, we can tell that it's not in the same file system as the path variable is. Okay. And continuing on. I think I'm lost track of where it was. Yeah, so we do .insert path as virtual. Where did I do the path as virtual is up here, right? Good. We insert native path to virtual, path as virtual. Okay, so that should be good then. The file paths that we'll be getting inside of the inspector should be virtual paths now, which means that when we go to do the find last of stuff, we only have to check against dots and forward slashes. Okay, so there we go. So on each one of these strings, we'll have to do the parsing. We'll get the position of the last delimiter. If we find one, and we always should find one, shouldn't we? Let me think about that. Yes, because if we're selecting a file inside of the content browser, all paths we get from it should be virtual drive paths, and that means that they always begin with a letter and a slash, possibly multiple letters in the case of the temp folder. But we're not going to be editing the contents of the temp folder, so yeah, that's a back burner item for sure. So I could just eliminate the slash, or eliminate the check for end position. But for now, I'll leave it. It's possible that there's an edge case that I'm not thinking of right now. Yeah, so if we find a dot or a slash, then what we were doing before is we were emplacing the string from the dot forward, I need to actually check whether it's a slash or a dot. So if path at pause equals a dot, then we will do this. However, if it's instead a slash, then we will have no extension. So what I did originally was I inserted the extension dot to indicate that it didn't have one. However, I could just skip it. If I did skip it, that would mean that selecting a range of items, and here's the point where I open up the other engines that I'm modeling. If we selected a range of files that included the one file extension and included a number of folders, that would mean that the inspector would not see the folders. And I feel like that's a bad idea. I don't like that idea very much. So I could insert an empty string. That's another option. Yeah, I think I will. I think I'll insert an extension. Well, instead of actually, you know what? I keep second guessing everything that I'm doing. Instead of inserting an empty string, I will track with a boolean. Bool has, let's say, folders in selection, and then if we identify a slash before the dot, then we'll say folders in extension, or folders in selection equals true, and we'll do the same thing down here. And that way the oh, and I need to put this outside of the for loop too. Yeah. That way the extensions only contains extensions, and we can do special handling for the folder. Okay. I'm just going to quickly check to see how these engines do it. So here's a folder with assets and a folder in it as well. I select the folder, nothing shows up in the details panel. Oh right, Unreal Engine doesn't do the style of inspector. That's right. So I'll be basing my modeling after Unity. I'm waiting for that to launch still. 1 minute 49 seconds. Still booting. Yeah, my impression of this will be that if we have more than one extension, or we have an extension and a folder in the selection, we'll want to display exactly what we have selected and allow to filter if we want. Right, so instead of all matching as a boolean, we will do let me think about this. I think when I was working on this yesterday at the end of the stream, I was imagining I would like have an early out if we have multiple extensions, but that's not going to work here because I need to still go through every single selected file to know what every extension is and how many of each there are. Oh, I'm not tracking how many of each there are. Let's do that. So instead of just doing a set, let's do a map. And it'll be a string associating a string with a size t, which is going to be a count. And this will be, instead of extensions, this will be num, or extension counts, I should say. Okay, and then instead of doing in place, we will do the square braces. So this will be the key. This should invoke the constructor for a string, so that should be fine. And then we assign it. Actually, no, we don't assign it. We do a plus plus, and we increment the count. That makes sense. Okay. Now, if we're counting the number of each file type, is Unity loaded? Yes, it has. So, like in the case of Unity, when we do this, do the selection style, it says narrow the selection. We have 5 cube maps, 2 texture 2Ds. And I like that quite a lot. I wonder if, yeah, it probably would make sense to track the number of folders we have selected as well. Yeah, so you know what? I'll do that, I think. The selected files have a size. I'm curious to know whether selected files has a size lookup in constant time. Oops, std set. Because if it's not in constant time, then I should just use an. I should just count up the number of files we have selected. Complexity, constant time. Yeah. And then instead of doing the Boolean folders and selection, we will do the same logic, except for the extension will be an empty string. Not a huge fan of this sort of a thing, but yeah, I guess it's how it ought to be. So we now identify when it's a folder, when the first thing we find is a slash, or if we don't find anything at all. Technically, this case, this cannot occur if the path is virtual. You know, yeah. I'll leave this here. I might issue a warning and say EP. I guess this would be not part of an API call, so I'll have to change my format of the error message. But I'll say I'll give a warning that a file or a folder is selected which does not have a virtual path. And that'll just give me a heads up inside of the this will give me a heads up inside of the console if the situation arises. I feel like it won't, but this error check will at least guarantee I won't crash if I encounter the problem. And we won't count such a situation as a folder because we're guaranteed in a virtual path to have a / next to the drive letter. Okay, good. This is coming together. Okay, and now that we've got a map of the extension counts, we can now do some smarter logic. So first we need to determine whether they all match. That's going to be done by extension counts dot. How would we count that? We can do size. How many? Is there a lookup for sets or for maps to do the number of keys? Huh. I guess not. returns the number of elements matching a specific key. Yeah, so we will need to separately track whether we've got more than one extension type. So what I'll do is while we are iterating through the files, I will have a size t that's going to be I guess extension counts is the name I want to use, but we're already using it up here. I'll rename extension counts to be files with extension. Num of files with extension. Okay, and then we have a extension counts variable. And we will increment it every time the extension we found doesn't already exist inside of the map. So below where we do the insertion, we will do plus equals plus equals a Boolean statement that is like this. Like that. So it'll plus equals the return of whether num of values with extensions.count equals 1. Because it'll equal 1 the first time it's added. If it equals 0, then we don't add. Actually, it'll never equal 0 if we're here in this block. If it's greater than 1, then we have already added it, and so we won't add it to the extension counts. So we'll say if extension counts equals 1, then that means that they all match. All right. And then if registered file inspectors.count num of files with extension.begin. This is a little different. Now we're going to be looking at the key of the extension. Number of files with extension. Trying to think of the best way to handle this. I guess it would make sense for us to do to cache the first extension that we have. We could do num of files with extension begin. If extension counts equals 1, we know that every single key. we know that the number of files with extension only has one key. Okay, so we would just use begin arrow first, and then that would get us the string associated with the count. Okay. It's a little awkward. It's kind of an awkward way to do this, but you know, whatever. Then we invoke the function like this. So yeah, so what I'll do is I'll do a const std string reference, and this will be the extension, and we'll set it equal to the first extension inside of number files with extension, and then I can just pass that in to these functions like this. And that'll be a little bit clearer to read. Okay, and so we do the function call here, then we do no inspector was registered and multiple extensions down here. Now with the multiple extensions selected, I can now plug in additional data. We'll say extensions, and then using the printf style, we can do formatted strings. So I would do one line like that, and then I would do for loop for int I equals 0, I is less than wait, I can just iterate through the, I know what I'm doing. I can just iterate through the number of files with extension. Like this. But it would be a const auto reference. What's up with you? Cannot bind a non-public member tree my pair. Why not? Number files of extension is a map with strings as the key and size t as the count. Oh, I'm using an equals instead of colon. So let me. All right, so we got a range now. Const string reference and a size t count. So inside of this block, we can now just do a line with the extension on it. So the formatted string will have a %s to represent the extension. Then I'll have a colon, and then I'll have the count, which will be a %d, I believe, for integer types. And then we'll do extension, and then count, like that. It's not very clean. It's not really interactive yet, but for now, it'll just display the information that we care about. And then no inspector was registered for extension. Oh, this is I am Gui code, so I don't use the braces. I don't use the Python style braces. I use the %s. But I do need to do quotes around it. And and then follow that up with the string extension. Okay, I think that's most of the way there. The main problem we still have is that I need to know whether the selection has changed this frame. So how do I do that? I guess I need the content browser to tell me when it's changed. Content. So I guess anytime we do dot clear or dot insert, I'll need to set a variable that is available inside of the inspector. Okay, so I'll go and do content.h. Right below where we have the declaration for the selected files set, I will have an extern bool. We'll say selection changed this frame, and then I will define it where I defined the selected files in the CPP file right here. I will default initialize it to false. And this will need to be changed to false every frame. We don't currently have an update, but we do have the draw call. It's occurring to me that the draw call is increasingly inaccurate with the editor code, because draw implies that all you're doing is drawing, but that's actually where we do the drawing and the interface. So maybe a different call would be better. But whether or not we draw the content browser, we do want to set selection change this frame to false. So that way, even if the content browser isn't visible, like if you collapse it or something, the selection change frame will always be false unless we have a direct change reported inside of the window. Yeah, so that would be selected files, and just double checking that I haven't forgotten something important. Erase, clear, and insert are the variables I care about. Right, okay. So, clear file selection, we will now report true for selection change this frame. So, select files dot clear. We will do set it equal to true, and good. And then selected files dot insert. Some of these will correspond to clear calls as well. Clear, insert, select and change. Yep. Selected files dot insert. And here we'll do selection change this frame as well. Then when we do the insert, path is virtual, we will say selection change to this frame. And once more here. Okay, and then the last one was erase. So if we're doing a deselection of a file using the control down, we do the erase call, and we need to do the change as well. Okay, so now we have a variable that will return true only on frames where we've changed the selection. That's very good. Inside of the inspector.cpp then, we can access it here. It would be content selection change this frame. Editor views inspector draw. Yeah. Do I need to do content? What scope am I in? Editor views inspector. Yeah. So it'd be views content and then selection change this frame. Perfect. Let's confirm that compiles real quick. Okay, something's broken. Expected type from format string was char. Oh, whoops. Extension is a SD string object and it's not compatible with printf. We actually have to do .c stir like that. Let's try that again. Okay, and count, oh, because I have to do a different letter for this. That's a ULL, or, can't quite remember what it was. I don't use printf all that often. I always have to look up what the letters mean. Okay, so the specifier is ULL. Even though it's not parsing it that way. Oh wait, hang on. Is it LLU? Is that what I'm missing? LLU, okay. And then, okay, that should be fine. Build that again. Confirm that warning's gone away. It has, okay, F5. And, okay, so I've only selected one file and it thinks that I've got multiple selections, multiple extensions selected. No inspector is registered for extension.txt. That's good. Okay, so there's something unusual about the case for the folders. If I go to, let's find a file that contains, or a folder that contains a lot of stuff. No inspectors registered for extension PNG. The .eptext is now blank because we got rid of that code from the textures.cpp. We'll fix that. If I do multiple selections, multiple extensions selected, extensions .eptext2, PNG 1. Yeah, okay, that's actually looking pretty good. I have an idea regarding the folder extensions. Before I was inserting an empty string, I could actually say folder here, and then when it goes to display it won't be dot whatever, it'll just be folder. I'll do it in square braces because it'll be, yeah, it'll differentiate it from the extensions that we see. I'll get rid of the quotes around, not that one, but this one. Oh, there's already no quotes around it, so that's good. Extension counts equals 1. For some reason, the folder was not incrementing the extension counts. So let's work through this again real quick. Extension counts, we go through every path inside of the selected files. We find the last delimiter. If the last delimiter exists and it's a dot, then we treat that as the extension. Otherwise, we say, hey, this is just a folder because it doesn't have a dot anything. Even though that's not actually accurate, you could have files without extensions. But for now, I'll just ignore that little tidbit. Maybe make a note in here. To differentiate between folders and extensionless files. Okay. That's realistically not going to be a problem for anybody, because when would you do that? When would you have an extensionless file? Okay. So we do plug in number files with extension whatever. And then we do extension counts plus equals number files with extension count. I think it had to do with the way we're constructing the string. Oh, because if it's a... Oh, alright, that's an easy mistake. Well, it's not an easy mistake, but it's one I made easily. Yeah, so I'm only counting extensions themselves, whereas if we're inside of here, then I need the key to match in this block. So we will do extension counts plus equals whatever it was that we plugged into the thing. All right. And actually, for that matter, we can make this a little cleaner looking. Let's do it real quick. We can make this cleaner looking by having a const char star. And this will be the extension, and it will be equal to null pointer at first. And then we say if we have a dot, then we know that it's the extension. We'll say extension equal to path.data plus pause. Else extension equals path.data, wait, no, equals square braces folder, like that. And then we just plug in the extension into this code down here. A little bit more elegant, a little bit easier to read, I think. Okay, good. All right, F7. I think that this is probably good enough. F5. Okay, no inspector is registered for extension folder. That's a little bit incorrect, but it's good for an MVP, I think. we can identify whether or not the thing has a extension on it. When I go to select multiples, it'll say I've got one text file here and 4 folder files, and so on. That's a little strange though. I select multiple folders and it says I got multiple extensions selected. Do we have that same problem inside of the textures folder? Yes, we do. So I just selected 3 PNGs. If I do 3 EP text files, it does the same thing. So it's saying multiple extensions selected, even though what I have selected is just multiple files. So that's a problem. So if extension counts equals 1, so extension counts is not being incremented correctly. Maybe it's an order of operations thing here. Num of files with extension.count. It'll return 0 if it doesn't have anything, non-zero if it has any. Yeah, so maybe it was like doing the plus equals and then doing the comparison after that. That's the only thing I can think of. Let's rebuild and see if that fixed it. F5. No, that's not it. So I'll have multiple items selected. I'll set a breakpoint on that code. And let's review what we got. Extension counts equals 3 here. Number of files with extension seems to be correct. It's got 1 key folder and it's got 3 counts associated with it. Oh, okay. Hang on a minute. Count does something different than I thought. I think count gives me the number of keys. The number of elements associated with the key. So I thought I was getting. Oh, that's so stupid of me. All right. I actually need to just directly access the value. I was thinking in my head that I was getting the number associated with the extension, but the truth was I was checking how many nodes there were associated with the key, and that there was only ever going to be one associated with the other, so that's always returned true. It was always incrementing extension counts. All right, cool. F5, rebuild and rerun, and then we should really truly move on. Oh, I got a breakpoint selected. That's okay. Let me undo my breakpoint. Cool. Multiple. Still says multiple extensions. What's going on there? Extension counts equals 6 now. What did I screw up? Oh, because I because I need this to be an inequality. I am being so dumb. Okay. F7, F5. Okay. No. Yeah. There we go. So now it's telling me no inspector is registered for a folder or whatever, and it'll only display the multiple text. Turn that breakpoint off when I've actually selected multiple of different extensions. Okay. So that's perfect. That puts us back on track where we need to be. I'll have to eventually, of course, go and beautify this, make this actually useful. Actually good looking. When we're inside of the Unity inspector, for example, we select any file, you have this little bar on the top that will always show you the name, the icon, and then you click open. You even have a reset for resetting the panel, but that's it's technically unrelated. That's a thing that you do for everything in the inspector. And it's a way for you to differentiate what you've got selected. I'll probably want to have something nice like that up top. And probably a global apply button. But for now, what we're going to do is we're just going to have the files that we have selected. They will, the inspector that we have registered for them will take over the entirety of the inspector panel, which means that they'll have to create their own apply buttons and things. Just real quickly, had to move my microphone a little bit. All right. So that's good enough for moving on, finally. An hour and 42 minutes later, bugs fixed, and implementations completed. All right, so now we are back into textures.cvp. We have the onInspector Gui. We have a true value if and when we've changed our selection, and this will be invoked only when we've got the texture asset files selected. So yeah, let's go ahead and make a GUI. Well, let's cache the values from the files. So what we'll need to do is we'll need to loop through all of the selected files. So we'll say if selection changed. We will do a for loop, range space for loop for every const std string reference file. I'll say file path equal or in selected files. We will open it up and we will populate our fields. So what fields do we need? If we open up the EP text files again, we have the type, we have the paths, we have the projection, we have the slices, and we have the min, mag, mid mode, and whatever. So even though we are parsing all of these, we don't actually need to store all of them in RAM. We only need to store one, and that's going to be what's displayed inside of the inspector. And then we need to store whether there's disagreement between the selections. So that way we can tell IamGui to make the field mixed. So what we'll need then is we'll need to go ahead and make variables for tracking this stuff. And I'm trying to think of the best way to do this. We need to make these persistent, make the storage persistent, so that it lasts beyond a single frame. However, I hesitate to just make it static, because that would mean that memory is always allocated, even when we aren't using textures or texture assets. It's probably not a huge deal, actually. So what we'll do is we'll just go ahead and make a static version of everything in the fields. I will put these first thing. So we'll have a static texture type. Say a type val, static minification filter, or sorry, texture filter. Two of these actually. And then the first one will be min filter val. And the second will be mag filter val. And then we'll do the static mip map mode. Mip map mode val. We'll need slice data, projection data, paths, and everything else too. So paths is interesting. Paths will have to be dynamic. So we'll have to do static std set of std strings. Does set make sense? No, in this case a vector would make sense. Because this is going to be a list that we're going to be extending inside of the inspector. We'll also need to rearrange elements within it. So on the one hand, it might make sense to rearrange the strings inside of a linked list, because you don't have to reallocate. Let me think about that. Yeah, I think that makes the most sense, actually. Let's do an std list of std string. And then this will be the paths val, or path vals, at least that makes sense. And then when we go to do the inspector, we can make them drag and droppable so that the order can be changed without reallocating the elements. Okay, and then we need slice data. So those are literally just integers. Yeah, so they're gonna have to be clamped between 1 and well, it's gonna have a minimum of 1 for the columns, rows, and count. I'll go ahead and make these unsigned ints. Slice columns, rows, and counts. Instead of putting val at the end of all of these, maybe I should do... Yeah, I'll just do like this, and we'll have somebody whenever somebody reads the code, they'll just infer that these are the things that we pass into the fields. And then we got slice columns, slice rows, and then we've got, well, I should do, yeah, I'll do the underscore thing for these, because I've got a lot of slice variables to go. Slice count, yeah. And then we've got static. We'll need a bool to determine if it's row major or column major. So slice is row major. And we'll need to give default values to these. So let's do that. Copy, paste. I believe these all have none values associated with them. Or no, I guess not. So we'll do nearest on, no, we'll do linear on the min and mag filter, because that's going to be the most common texture filter that you'll want to pick. And then map modes. We'll say none for default on that. Okay. The texture type, we do need to set a default for that. That'll be, I'll set it to 2D for now. Actually, no, I'll set it to none. We won't. This will be what the field would display by default if we don't have. Yeah, the defaults will never actually be displayed. I just need to have it set to some value prior to. We just need to have these initialized. That's all. Technically speaking, none of these will be displayed before they get populated with the contents of one or more files. So we're okay here, I think. So we've got a bunch of variables now to fill with stuff from the YAML file. We're going to go ahead and use the rapid YAML still. We already have it in use elsewhere in this file. So we'll need to get the contents of the rapid YAML tree, and then we can parse that in place. So we'll do an std string. This will be file data, and we will fill it with file. Wait, no, this is going to have to be a separate call. I'll have to do if file load text file and pass in the file path, and then the address or by reference we pass in file data. I think that should probably be a pointer in that API call. And we'll say it equals error code, except for that's file error code success. So if that's successful, then we do this, else we say else one of the files hasn't loaded. What should we do if there's a failure to load a file? So if I select multiple files and there's something wrong with one of them, what should we do? I suppose what we could do is we could deselect it. We have access to the selected files list. So we could deselect it and issue a warning saying that we can't inspect this file. But then that would cause undesirable effects when you're selecting the file by itself. So we won't change selection. But we'll need to issue a error. So we'll do EP error. And this will have to come from the inspector, I guess. I'll have to think about how I want to format my error messages in custom inspectors. But I'll put it as like textures. No, I'll do it as inspector like this. Inspector. And then I'll pass out the file and the error. Actually, no, because the error will be printed out anyway when this fails. Cool. So we'll say error opening file. for user experience stuff, we may want to add a refresh button. But I do think we'll want to add Gui text. So we'll do a color. This will be an IMVec4, so I can just do like red. And then a formatted string, which will be error opening file path. But it'll be path.cstring because this is a printf style, and then this will be, instead of curly braces, we do %s. Okay. Error opening file, blah, 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 and then we move on. All right, so if the file has opened, we need to store and compare the first value. So it's a little bit awkward because I want to drop the first file that we come across and iterate only through the rest. Because otherwise I have to have an awkward tracking boolean and then compare against the first. Yeah, you know, I'll just do the boolean. We'll say bool. Really hacky, but I'll worry about beautifying my code later. We'll say if it's not the first file, don't forget to set isFirst to true. Down here, if this is not the first file, then we will populate without comparison, else we will compare against what we've stored. Okay, yeah. So we'll probably need a helper function for this going forward. And the reason why I want to go for a helper function instead of just implementing the code is because we're going to need to be able to load the contents of a texture file later as well. We have part of one. We've done some rapid YAML parsing before. So down here when we go to load texture, we have previously just directly loaded it and then got this stuff out of it and then passed that into the implementation. However, I'm going to move this to its own file because we're going to use it in more than one location now, or into its own function, sorry, and because we're going to be using it in more than one location. So let's find a good spot. I guess right above the on texture inspector GUI is a good spot. So this will be a static void. And it'll be like parse texture parse. What do you think about this? It's not texture data, it's metadata. Let's do parse texture metadata from YAML. And then this will receive the buffer which we'll load in on Inspector Gui, and we'll also load it when we go to load the texture in the engine. And then we'll need the address of all of the variables that we will set. So that'll be down here. Let me find. Oh no, it's right below where we were. So that's all of this stuff basically. So I'm just going to copy and paste it real quick, and then do a quick little bit of formatting to make it suitable for use in the attributes or the parameters. Just took a long shower thinking about my codes. Love yes. Shower thoughts are very useful for programmers. That's for sure. How are you doing today, Yolan? Okay, texture type, std list of strings, paths, min filter and mag filter. Oops. And bitmap mode. I'm fine, and how are you? You're at it every day. I have been. This whole week I've been at it. Like, I mean, I have other projects periodically that I'll do in between coding sessions, but right now I'm just really focused on getting a demo, something that I can show off for job applications. So I guess I'm spending a lot of time on this. We're making a lot of progress, so I'm pretty happy with where this is going. Very soon we'll have the ability to do really advanced looking materials from inside the editor. Okay, so these are all the parameter types that we'll need, except for I do need to make these pointers. Boop, like that. A little star at the end of it. And then I will cut and paste, and we'll need commas after each of these as well. Bam. Okay, it's going to be a lot, but this is going to be an internal function, so I'm okay with it being a lot of parameters. With your experiences and skills, aren't you able to lead dev projects? I don't think so. The trouble is that I've never been hired as a programmer, and even though I believe I'm probably more capable than most of the students they hire, and probably no more than most of the students they hire, the fact is that I represent a risk, and there's a certain amount of ageism involved. So I have to kind of like do something that'll blow people out of the water before I'll get a chance, I think. But that doesn't have to be your situation. Just make sure that you've got you actually go to school for this stuff, or that you actually work on projects that will get you a foot in the door. And the earlier you start, the better. Okay, so I think this is fine. The YAML in buffer is a const reference. Everything else is a pointer, and that allows us to use these as outs. I should probably. This is a stylistic thing that's very helpful. When you're using out parameters, it's helpful to use the term out like that. They're by pointer, but by putting the term out on your parameters, it makes it very clear to whoever's using the function that you're putting the address of something that you want to receive the data. Cool. And so now we've got a function for it. This is an internal helper function. We can go back to that code we wrote yesterday. Where's our YAML? Okay, here it is. So this is where we were doing the stuff yesterday. We had the load text file, and then we make the RYAML tree and stuff. So everything here, from here on down, we can just take that and put it into that function. Control X. When you see a guy in a Bugatti or a Ferrari or a Lamborghini, do you think that that guy went far in schools? For successful people aren't doing things the way that the normal job taker does. Yeah, I suppose so. But that's also a little bit of a lie, because a lot of the folks that are driving those things around, Bugatti, Ferrari, Lamborghini, it's not anything that they do that got them those things. They started out with the wealth, and then, yeah, wealth begets wealth. Yeah, if you're talking like a zero to hero millionaire or whatever, then sure, yeah, they broke the rules to get far, but I'm not one of them. Okay, so here we go. We've now moved everything in to this function from before. We start with a YAML in, and then we can construct a tree and then do the parsing and then store them out in these variables. So all the parsing code is actually already there. We did it in our previous session before. However, the YAML in is now, or YAML source is now YAML in, so we'll replace the name there. And then we do, what's up with this? No overload, no instance of overloaded function matches the argument list. YAML in, parse in place. I'm a little confused. Paths out is the only list I see here. Matches the argument list. Oh, listed matches the argument list. So the type that I'm passing in is wrong. Const to string to substring. Oh, it has to be mutable. That's why. Okay, so actually, yeah, this has to be mutable. So what I'll do is I'll do a const substring. And if it's not mutable, can we parse in place? I might need to have a mutable buffer passed in. Yeah, you know what? I normally will, when I'm doing something like this, where I pass in a string from one place to the other, I usually will do a const reference. This is a case where I'm actually going to do a mutable reference, just for the sake of saving an allocation. Again, this is a private API. It's only for me for writing inside of this CBP file, so I'm actually okay with giving myself a mutable input. Okay, we got the tree. Error, the root node of the texture asset file is not a map, and we want to pass in the file. Oh, and we don't have the path to associate with error messages. Does that matter? Do we care about that? I guess we do. So, So how about this? Instead of passing the YAML sourced in, I will instead pass in the path to the file, and we'll actually do the file loading inside of this function. And this will just be the path. And then we'll head down to where we cut this all from, here, and we will we'll do a few things. We will cut, ooh, we're going to need to remove this from an if block. I'll do a cut on here, and I'll paste it inside of the new helper function. And then I feel like I should be making use of bookmarks. I've so rarely needed to have bookmarks inside of VS Code that I've forgotten how they work. But maybe this would be a case where I should use that and zip around a little bit faster. Let me double check how that works. Oh, I guess it's an extension. Okay, let's add bookmarks. Okay. Yeah, okay. And where's my tutorial? Don't see a tutorial forthcoming, so I will just do it myself. Bookmark. Selection to next. Toggle. Control-Alt-K toggles a bookmark, and then we have Control-Alt-L to jump. Control-Alt-K, Control-Alt-L. Okay, so I'll do Control-Alt-K, got a bookmark, and then down where we're cutting all this from, I'll do Control-Alt-K, and then I can do Control-Alt-L and bounce between them. Perfect. That's really handy for this file. I try to keep my files short enough that this never becomes a problem, but this is kind of just how textures are. There's a lot of little details to worry about. Okay, so right. So up here then, this would be where we do the parse call. We'll need to think through this restructure. So we're doing the texture reference counting here. If it's already loaded, excuse me, if we've already loaded the texture, we will then just increase its instance count and then return the texture handle. And then the else block is where we do the loading. So I'll need to have locally declared variables for these, and then I will receive them as outs, and then I can pass them into the texture implementation. So let's head back to, oh wait, I forgot to do this. Yeah, to get back. I will need, in the function call below, we have this block. I will need to bring that into here. Except for in this case, they are not static. They're just variables. And I don't need to initialize them either. I mean, you could argue that you should always initialize, but no, you know, I will leave them initialized. Okay, and then we will do parse texture metadata from YAML. We'll pass in the path, and then we will pass in the address of all of these. So type, address of path, Wait, there's more than one path. Paths. Oof, hang on a minute. Texture paths, I guess would be the best way to say that. And then in filter, mag filter, bitmap mode, slice columns. I can copy and paste these. Oops. Unless you forget to hit Control C, then you can't paste them. And then address of, and then commas. Okay. Cool. And then I believe that's it. Yeah. So we do the declares, the locally scoped stuff. Then this will populate them, and then we will have them for use here. All right. Oh, I'm missing my projections. Okay, hang on. Slices, and we'll say cube map projection equals, we'll go to default for none. Okay, and then we need to insert this into the API as well. I keep calling it an API, but this is not. This is just a helper function. Bookmarks are really helpful for this sort of thing. So I'm really glad I took the 5 seconds it took to install and learn how to use the extension. And then this will let me copy the type. All right, and good. What's going on here? Right, the implementation is expecting a vector of these. The reason why I wanted to do it as a list is so that I didn't have to do copies when I went to sort. I'm not even sure off the top of my head how you do that. USDD list. A change that calls a change that calls a change programmer life. Yep, that's how it is. The frustrating part about this project so far is that it's an engine, so by definition, everything I'm doing, almost everything I'm doing is really low level stuff, and it's cool when it's done, but it's not. I'm not actually working on the game. I'm working on the engine, and so it's it's not flashy, but it is really satisfying when it gets done. Yeah, I really quickly want to confirm, because I've never actually even bothered to use an STD list in this way, where you can reorder the elements. There's sort, of course, it's easy to use, but what I'm curious about is how easy would it be for me to like shift up and down a element. I suppose what I would do is I would grab the node and I would say insert. Except for the insertion is not, it copies. It might be better for me just to do my own linked list instead of std list in this case. Almost every search result thinks that I'm trying to sort, and that's not what I'm interested in. Whatever. I'll do a vector for now, and then I'll worry about reordering when we actually go to do that API. The thing that I'm thinking about is that when you're working inside of the inspector, you're gonna care about what the order of the files is, and so I want an ImGui to be able to drag up and down file names. And it would be great if I didn't have to do reallocations when I did that reordering. So for now, I'll just have to do this as a vector and then worry about the editing when we go to do the editing. I remember at school they made us create our own collection using pointers. That was cancerous. My point. Yeah. Well, it's so flexible though, right? It's. I mean, like linked lists are not complicated, but it's like. I mean, like it's easy to screw up a little thing because there's a list of things you have to get right before the linked list will function correctly. But just to have that flexibility. Like if I was using my own linked list structure instead of std list, then it absolutely would have the ability for me to just like say, take this element and make it the second, please, and then automatically automagically do it with a function. But yeah, so I think this is one where I'm gonna have to step away from the STL when I get there. But for now, I'm just gonna do vectors and not think too hard about it. So this is now a vector. And so is the API. Or so is the helper function vector as well. And yeah, we'll just kind of go from there. All right, so YAML source, so we say if load text file path YAML source is success, then we can do this business. We have YAML to substring. YAML in is undefined because now we are using YAML source, which was parsed above. I suppose I can call this YAML in, but I'll leave it as YAML source because I have it typed in the code we copied already. All right, if the root node is not a map, then we've got a problem. I'm going to change the return value on this guy. And I'll return false if there's a problem. Because once we've got the metadata parsed out, we're going to need to decide whether to load the texture. So we'll use the return value of this to determine that. Okay. Same thing here, here, and I think that's the last early out. Okay, then we get the paths from the file as well. However, instead of, let me think about this. Instead of doing a string view of paths and a vector of string views, I'm going to want to actually copy them out into the paths out buffer, because once we leave this scope, the buffer will be gone, so we can't string view it anymore. I'll get rid of this. And then paths is now going to be, what was it? Paths out. It's just paths out. Right. So this will be paths out. and we're going to be constructing the string in the back of it. Hey, I got a question. Is it a bad practice to put rendering in its own thread so that it has like 100% power? It's actually a great idea to put rendering in its own thread. That's a very common practice, but it's not for the reason not for the reason you'd think. The main purpose of putting rendering into its own thread is to prevent the synchronization of your main thread from getting it's to prevent it from getting in the way of timely submissions to your graphics API. So in OpenGL, for example, a very common thing to do is to have your thread that does your game stuff, and then when you're doing the game stuff, you'll be updating the state and maybe pushing instructions to your rendering thread to render things. And your rendering thread, its only job is to listen to those commands from the main thread, and basically it will, as soon as it has a complete set of instructions to draw a frame, it will submit that to the driver, and then it can sleep while waiting for the synchronization from your display. And that's the main reason why you do it. It's not to get more power. It's to make it so that your synchronization to your display is the only thing that's in the way of your rendering code. Otherwise, you could run into a situation where your scheduler could schedule time for submitting stuff to the graphics driver, but because your main thread is kind of like inconsistent with its frame times, like you would be missing out on an opportunity to update the screen. It's a little hard to describe without charts, to be honest. But yeah, it's absolutely a great idea. But the key, the thing to look out for is that you're not doing it for the sake of maximizing your GPU or CPU or whatever. You're doing it to prevent downtime, to make the game simulation more fluid, I guess, or more faster to update. I hope that made sense. Right now, I'm not doing that. I'm just doing single-threaded, and eventually, when we get to final touches, like optimizations, I'll be looking at doing a rendering thread that will just take the commands submitted by the graphics API and then have just a thread do that in the background. Path node trees. Okay, paths out, dot and place back. Except for this is a vector of strings. Expression must have a... Oh, it's an arrow, because it's a pointer. That's right. Paths out, in place back. Right? Why are you complaining? The vector of std string Yeah, I don't understand what the problem is. Well, let me head back to that in a minute. Texture type, node type. Instead of doing direct assignments here, I do need to pass out the data into these out variables. So instead of doing texture type, we will do a dereference of type out equals stir to texture type, and we'll do the rest of the code based on this principle that we're directly assigning to the out variables. Okay. Yep. Type out. Good. And then paths. Got the path node, and then we got paths out. We have place back. Yeah, I knew it wasn't a problem. It was just taking forever to correct. Okay. And then instead of doing type, we have the reference of type out. And then instead of doing projection, we will do projection out. We'll assign okay. And I'll come back and control F these as soon as I get to the bottom of the block. Type out. Slices, get rid of these. And then these will be slices underscore thing, I believe. Or is it just slice underscore? Slice underscore. Still got some complaints though. Oh, because I have to add out to each of them, right? Okay. All right, so now we got all that parsing code. Broken out into a separate function. I'm going to quickly control F inside of the function and replace return 0 with return false. Okay, that's looking good, I think. I'm not entirely clear if I have a return true in every case, though. Actually, I don't have any return trues, so I had to do a return true at the bottom. So we just return false when there's a problem, and then if we make it to the end of the function, then we return true. Perfect. All right, now we'll head down to where we were using this, and there's sure to be more refactoring to do. So we've got a local stack allocated variable for each of these. We then parse, passing in the path, and then we have a boolean that we need to track. So let's add that. Bool loaded success or load success full equals parse texture metadata from YAML. Though now that it's taking the path and not the YAML buffer, maybe I should rename that. Yeah, let's rename that to parse texture metadata or load, because we're not just parsing, we're actually doing a load from file. Load texture metadata. Perfect. And then if it's successful, then we will do the rest. If load successful, then we will do this stuff. Okay, and then we have an else block down here, which Let me make sure I'm following this correctly. So we have if it's not already loaded, we do the loading inside this else block. I'm missing a square brace. Okay, yeah. Right. Stop it. As long as this else block returns the texture, then we're good. Okay. Sweet. So if load successful, we will do the logic as before, using those stack variables instead. Otherwise, we'll say unable to load texture asset. I think is what I'll say. Passing in the path. Do I have good error messaging on the helper function? I'm looking for a failure to load. I should bring that warning, this else block, up into the helper function. It's more appropriate there. Yeah, if the load text file is not equal success, then we will say unable to open texture asset. Okay. Good. Good. And then return false, of course. So wait, I think that's most of the work done. So if load successful is false, we've already got an error message and we are moving on. So we'll do if load successful, else return 0. Yeah, okay. So we still got some more warnings here. Texture paths. We're now passing in. No, we are passing in texture paths. Vector of strings. Oh, but I need to pass these in by pointer, and I need to pass in the path. No, that's not right. What am I missing? Type const. Okay, the implementation is expecting vector string views. Oh man. So the helper function, the thing that I'm not liking about this is that the helper function is now responsible for loading the file. And it keeps the buffer. So it allocates the string that contains the YAML, and that buffer is used to create the tree from which we parse the YAML. And that means as soon as we return from the helper function, we don't have access to the string anymore, which means that I have to take the string that we already allocated and allocate it again, or at least, or even worse, allocate multiple times to bring in each element that we wanted to keep out of it. In this case, it's every path that we store. I'm going to take the path loading out of this function. I'm going to switch this back to what we had in the first place, which is a const std string for Yaml in. And then we'll assume that it's already loaded. And we will do a vector of std string views. And the advantage here was that in the main use case for this function, when we are loading assets for the first time, we are not doing a bunch of reallocations, which will make game launch times shorter. And then in the case of the inspector, we'll just have to bite the bullet and then allocate those separately. And that'll be a much smaller bullet to bite because of the fact that it's only being done once your selection changes inside of the content view. So yeah, I think we're okay. I think that's a smart decision. So back down to this guy. We will do oops, that's not what I wanted. I wanted to cut the I just forgot to do it. Okay, so if load text file okay, if load text file path YAML blah 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 blah, then we will do the tree and stuff. So I'll cut that. Paste it here. And then scooch it up because it belongs up above. And then, oh, I broke the other bookmark. Grab that else block, Control X it, and then put it so much red, I would panic. Yeah, it's refactoring. I've got a good chunk of this is still committed, so I can actually roll back a lot of these changes. Where's the Inspector Gui, low texture implementation? Is that texture properties? I'm having a brain fart and I forgot the name of the function. There's the low texture metadata. It's used inside of just regular low textures actually. Here we go. All right. If the file loaded, then cool beans. Else, there's a problem. Okay. And Alt-Shift-F seems to format that correctly. This needs to go up one level. All right. So this is the if block for if file load text file. Good. And then this is the else block for it. And we return 0 again. All right. So I'll need to do an std string YAML source again. And And then we got the load text file. So we have the YAML source to work with. We have the local, the locally scoped variables. This is now a vector of std string view. And when it comes back, we will have everything we need. Okay. Rows, columns, and count are integers in the implementation function, but I have them as unsigned ints here. I'll just make these ints. I don't see the benefit of making them unsigned ints. The load texture metadata function, which I'm gonna make a bookmark again for. I will call that ints as well. Cool. And then, yeah, then down here, I should have made a bookmark here as well. I'll do that now. So I can flip between them like a freaking madman. All right. And then inside of load texture metadata, we now can construct. We now got the YAML in as a const reference. Oh, and that's right. I was gonna make this as a mutable reference, so that way we can do this correctly. Parse in place. And because we're parsing in place, even though the tree is constructed inside of this scope, the buffer still exists in the outer scope, so we can use string views into that buffer all the same. Cool. It's just the one thing that we're giving up is the ability to display the path in the error message. And that's not really a huge deal for me. Not a deal breaker. I think once we've gotten this to compile, I'll take a little break. But okay. Yeah, we can just get rid of. Now that we're using the helper function in multiple API calls, I'm now going to start putting it in the error messages to make it a little bit more clear where the error messages are coming from. Oops. Okay, nearly done with all the warnings. This is the boring part, but still very important. Okay. That's looking better. Looks like we resolved all the little red squigglies. And I'm just going to quickly confirm that inside this block we don't have any graphics load texture errors. And yep, so it means I got them all. Cool. And that's resolved the warnings for load texture metadata as well. Rows, columns count. Those are now slice rows, slice columns, slice count. Projection should be after. Should they be? I want to be consistent with my logic. It's much more likely that you'll be using slices than cube map projection details, so they're kind of mutually exclusive. So what I'll do is I'll put them below. Okay, so this is now the priority order. We do type, paths, min, mag, map, wrap mode, and then we do the other stuff, the slices, and then the projection. And then it's in that order. Slices first, and then projection, because this is going to be more common, and this is going to be less common. And changing up the order of the stuff inside the YAML file has no bearing on its functionality, by the way. So I'm okay to do that and leave the other files if I want. I'm just doing that as a point of reference to compare against. So the implementation, now we will move the cube map projection to the last, and we'll do the same thing in the header. Wait, textures .h EP internal. So yeah, we'll do the same thing here, like that. Good. And head back down to this code. Good, and now the projection just needs to be moved to the bottom. Okay. Very nearly done with the red squigglies. All right, and this code needs to be moved up into the load texture metadata. What I was doing before was I was attempting to load the images before I loaded the bitmap filter modes, because these are technically optional. However, that's not the case anymore. Now these have to go inside of the metadata function, so we'll reorder it. Hey, what's your opinion of design patterns? Do you use some? Yeah, I mean, design patterns are just, you know, how you think about problems. So like, there's plenty of places where we'll follow a particular paradigm. One that we're going to be using, the one that's in the forefront of my mind right now, is the command pattern. That's something we'll be using fairly soon to implement undo and redo. Basically, you just you make objects, or you make it's usually a struct or something like that that represents an action in your undo and redo history, and then you can make arrays of them or lists of them, and treat that block of data as an undo and redo history, and you can apply the functions that they point to as you go. And each enterprise game is based off of a global state machine, so it uses the I think it's just called the state pattern, where you take and you encapsulate a state in a class, and then you swap those out, and the virtual calls will handle changing from one mode to another, from one behavior to another. But yeah, they're good things to learn. They're used in a lot of interview questions if you're thinking about jobs. Just tools in the tool belt. Okay, so this whole block then we cut. Okay. And suddenly this function is looking way simpler. We load the metadata, and then if we were able to do that, then we load the function using the stuff we got out of the... Yeah, okay. So let's head back to the metadata function. And then we need to add here. We'll need to add the stuff. I know it's dumb, but I also love singleton. I think it makes code clearer and less prone to error. See, that's I'm not a huge fan of singletons. And actually, this is a polarizing topic. You're going to find there's some people who are fans of singletons, and there's some people, probably more people, that dislike singletons outright. I think singletons is like, it's just for me, singletons is just the way to avoid globals, and like you can probably tell from my coding style from what I do on the stream that I'm very functional. I do functional programming for the most part in Enterprise in my game engine. So I'm actually totally fine with doing a whole bunch of global things global functions to do things instead of doing classes and instantiating systems. But it's like singletons, like their main purpose is that you allocate them dynamically, but only once. And I think the main perk of doing that is to like avoid having it initialized at static time. And I do want to be crystal clear that I do use singletons. Like the entire engine runtime is a singleton in this. And the main reason why is because I wanted to avoid static initialization. I wanted it to be something that is initialized after all the static stuff is initialized. And I wanted it to trigger a stack unwind when we have an insertion throw. So it's a very specific use case, I'll say, that we'll use singletons. But in general, I'm not a huge fan of it. I think that if you're going to use a singleton, you should probably just use global functions. And you know, I guess if you're working in C#, and if I'm remembering correctly, you're more of a C# person, then you kind of have to use singletons because everything in C# is a class. In C++, I'd rather just do globals, to be honest. And you'll find a whole bunch of C++ programmers that completely disagree with me on that too. It's a divisive topic. But it's a good tool to know. You should know the singleton pattern if you're going to be applying to jobs. Okay, so previously I was only calling this code if the texture itself loaded successfully. I don't need to do that check anymore. I will get rid of it. Trying to find the... Okay, it would be here. Find that extra... Wait. There's an extra brace somewhere. I think it's... Just trying to follow the line down. I think it's here, actually. Let me reread what I've got. Got the parse in place, got the tree check, the type node check, and then we get the type node, and the path node check, and then we get the path node, and the projection. We got slices. The last job I had was so boring. They had made a big enterprise framework for CRM, for a CRM. Everything I had to do was adding 6 to 7 interface, copy and paste 10 lines of HTML codes, and voila, repeating task all day. Yeah, it sucks, but a lot of programming jobs is kind of boils down to that, from what I hear. There's something weird about the code I pasted in. I'm not putting my finger on it. Oh, I did it too early. That's why. Oh, okay. I need to be pasting it down below. Okay. But it led me to thinking what type of works those interfaces are doing. It just got you thinking about it, about the purpose of interfaces, or what they're supposed to be doing. Okay, here we go. Yeah, I think I'm on the right track. Right, so we've got the slices. Those are being put into the slice count out, or the slice out variables. And now this is where we do the property getting. The stuff that we get for setting OpenGL properties, specifically. Min filter, mag filter, min map mode. We do need to have these as nodes that are on stack. However, instead of assigning these to stack variables, we will assign them to the outs. So dereference underscore out. And the same thing here, dereference underscore out. Okay. And so now we've parsed and we've outputted the min filter, mag filter, and min map mode. Okay, and then this here is intended to be a warning about the dimensions of the texture. This does belong back in the implementation function. So I'll cut this and the set texture properties. And the tracking bars. Actually, all of this needs to go. Control X. Cool. Well, I was used to web dev in Java using ORM and JSON page and Java toolset, so everything was made by hand and not centralized. That CRM had like 30 to 300 pages, and I was doing so much stuff, yet I was doing HTML job at the end. Yeah. Sounds like fun. Okay, I think I'm doing pretty well now. All right. Right, so we load the metadata into these stack variables. Then we, if that's successful, then we do the implementation call. And then after doing the implementation call, where's the, down here. we have to set up the properties. So in this case, we use the mitmap variable up here. If we are mitmapping, if we're generating mitmaps, then before we set the texture properties, I do a quick check to see what the dimensions of the texture is. Oh, but I don't have do I have the dimensions of the texture? I do, because it's populated inside of the load texture implementation. All right. So once this call returns, we will know the dimensions of the texture. I get them, and then I do this quick little bitwise math trick where we take and subtract 1 from the width and subtract 1 from the height, and then we do a bitwise and to see whether or not they equal 0. Because if you think about it, a power of 2 number will, a power of 2 number will be just a 1 and a bunch of zeros. So if you subtract a 1 from it, then you have a bunch of 1s. And if you bitwise and those together, then they actually cancel out because it's the 1 and a bunch of zeros. And then starting from that digit back, it's a bunch of 1s, and the zeros will cancel out the 1s. And so if it equals 0, then it's a power of 2. Otherwise, it's not. Are you using OpenGL to render the GUI of your engine? I am. The GUI of the editor, I'm assuming you mean. I am GUI, technically speaking, but I am GUI is compatible with a bunch of different backends. So when I went to use I am GUI, I told I am GUI, hey, I'm using OpenGL, here's my OpenGL stuff, and go to town. And so I'm not strictly speaking doing the rendering code for the editor GUI, but it does ultimately get submitted into my renderer. I don't know if that makes makes a lot of sense. All right, so I think I'm there. I think I've got everything working. However, when I went to compile, I've got some problems. So what are we looking at? Cannot initialize a parameter of type int with an R value of type cube map projection. Where did I screw up? Oh, I reordered. Yeah, in the content browser where we load the file and the folder icons, I reordered these parameters, and I didn't make the change here. Okay, F7 again. Moment of truth time, see if we broke everything. Oh, it built. And if I press F5, okay, it opened. These textures seemed to load. Let's load a scene. These textures did not load. Okay, so that's a problem. Let's go to the console. See what we got. The root node of the texture asset file is not a map. Huh. Now, strangely, I only see one instance of that. It kind of seems like, yeah, so none of the entities have sprites on them anymore. Let me try this again. No errors so far. Low texture metadata, the root node of the texture asset file is not a map. But I should have loaded like 3 different textures. So I should be seeing this error 3 times. Or I should be seeing the other sprites when I move the camera around. But none of the sprites have the component. I guess let's set a breakpoint at that error. The root node of the texture asset file is not a map. Oh, it's probably broken up. Okay, here we go. I'll set a breakpoint on it and see what we can inspect. Let's open up a scene file. Okay, parse in place. We're using parse in place on the YAML in. The YAML in. Oh, I'm still receiving the path. Oh, okay. Hang on. I needed to switch to sending the buffer in again. Okay, that's probably it. Recompile and rerun. F5. Okay, now the scene's loading again. So, cool. Now we don't have any errors or warnings either. Sweet. And yeah, it's still pretty fine. Cool. This second scene file fails to load because it's got, it's still referencing PNG files instead of EP text files. But yeah, I think we're off to the races. Let me go back to the textures. If I was to select some files and drag a text file onto it, it loads correctly. We are doing better. So now we've got that split off. We can, inside of the on texture Inspector Gui, we can now parse this data out using that helper function. So we have all the variables here. Well, we have all the variables except for projection, so let me do that. Type paths, and this has to be a vector of string views. Because that's what the function returns. And then we can call parse, sorry, load. Oh, wait, I gotta change the name again. Always something. It's not load texture metadata anymore. It's now parse texture metadata. Yeah, and then back to on texture Inspector Gui. I'll set a bookmark here so I can zip it back to it, and I'll turn off this bookmark. Okay. Now that we've got all these stack variables, I can now do parse texture metadata, and we need to pass in the block for the first file. Yeah, okay, I think that makes sense. So the first file is going to be selected files. dot begin. And we're doing this inside of if selection changed. Now that I'm realizing this, if selection changed. We'll do an if we'll actually do, I'm going to do a little bit of a trick. I'm going to do a while loop without any code in it. Wait, can I do that? Can I? Are you eating something else than codes? No, I'm not. I'm not eating, I don't think. I think I would know. Checking my mic levels. Think about this. See, so what I have to do now is whenever the GUI code gets invoked. So whenever I need to do an inspector for the texture files, I will have to check to see first whether it's a new selection, so I know whether to hit the file system, and then I have to go through all of the selected files and parse out and compare their data. So there's the possibility that the first couple of files I've selected will have problems. I think what I'll do is that if there's a problem with any of the selected files, we will simply post an error message and then not continue. I think that makes the most sense. So I'll do a buffer. So this will be a SD string YAML buffer. And then we will say load the first one. Oops. Like this. And yeah, then we pass in the first path in selected files. And this is a set, so let's do begin and dereference it. There's no front or back on selected files. However, I don't actually care which one I get. I just need to iterate through all of them. And so I just use begin and dereference that. And then YAML buffer is going to receive the data. So if that's successful, great. Then we will do the parsing on this YAML buffer. And we will need to pass in the address of all of these. So let's do that. Type paths min mag mip slice 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 0 major projection. Copy. Paste. And then get the address of, followed by commas. And yeah. And what's the problem now? Oh, because these are still unsigned ints. These should be just regular ints. Okay. So just like that, we've got local variables to track this. These are static because we want to make this persistent frame to frame. There's only one because these correspond with the fields in the inspector, not the actual contents of each file. We have a buffer, we grab the first file, we load it into the buffer, and then we parse out the things we need. Cool. Now that we've done that, this is going to be the starting point by which we compare values in the inspector. We need to check we need to go through all of the files, and we need to check whether they match or they differ from the first value. If they differ, we will display the field as a mixed field inside of the inspector. If they don't, then we will display the value. And when you make the edit, you can see the change affect the mixed fields, just like you would expect inside of Unity. All right, so this gets a little weird because of ranges. Technically speaking, we are parsing this file twice, and in the first iteration of this loop, we are comparing the first file against the first file. So I'm just going to hack my way through this a little bit. I'm going to say bool is first equals true. We'll say first loop. How about that? And then we'll say if is first loop, then we will set is first loop to false, and then we will continue and skip over reading this file again. Though, if there's, let me think about this. If there's a problem loading the first file, then we need to present an error. So I'll do that here. Gui color text colored, I think is what it's called. Yeah, text colored. I pass in a color of red. Wait, can I just? Is there an Gui red? I think there's like a macro for red, and I don't really remember what it is. I guess not. There's ones for black and white, but not red. So I'll just do a instruction of 1, 0, 0, 1 for the color of red, and then the formatted string will say error opening files, or one or more files. Okay, and then, yeah, okay, so then we do the loop comparison down here. So we have to do the load text file to populate the buffer again. Oh, hang on. First time seeing color coming from Vec4 used to RGB or lazy coloring. Yeah, the Gui actually supports both. There's two APIs for almost everything involving color. This particular one happens to take Vec4 color components, but there's also a U32 version where it's just bytes, and you pass in the byte values just like you would for hexadecimal. Or for HTML, I meant to say hexadecimal like you would in HTML. And I'm just realizing right now that there's a bit of a problem. If I go to load the text file again, this will clear the contents of the YAML buffer, which means that we're invalidating the string views and paths. So I do actually have to copy these into a local buffer. Alright, that's not a huge ask, but it's annoying. So what this will be is that this will be an actual std string vector. And then we'll have to do a local std vector of std string view to house the paths. So this will be paths as views, and we'll pass in the address of paths as views instead. And then I'll need to do this in an if statement. If this returns true, okay, there we go. If this returns true, then we will do a copy into paths from it. Can I do? It would be great if I could just do paths equals paths as views. I don't think that that's how that. I don't think that the class is smart enough to know that I'm trying to copy the data and then construct each element. So what would be the easiest way to do this? I could do a loop and just construct each one. I wonder if there's a way for me to like insert all of them at once. Let me look at this. So we can do an insertion iterator. What do you think about this? Well, for starters, when the selection changes, we do have to clear the vector of paths, this thing up here, because we need to repopulate it. And then I could probably do paths.insert and insert a range. So it'd be paths.begin is where I'm inserting. And then the list, I think I can do from, iterator first and last. So I can do an iterator first and last inside of paths as views. I just don't know whether the constructor will convert these. It may. I'm not getting any warnings here. So I guess when I go to compile, we'll see if there's a problem. But I think what I've got going here in this one line is that it will iterate through paths as views, and then take its value, which is a string view, and then copy them into paths at the beginning. And if I'm following this correctly, that will automatically invoke the constructor where you construct an std string from an std string view. So hopefully this will work, but this may cause a problem. So we'll see. Worst case scenario, I just come back and do it the old-fashioned way, and I just do a loop through and do the conversions myself. All right. And then we'll have to say else on this, because if we are not able to parse the metadata, then we need to present a warning and then continue. So we'll say copy, paste, error opening one or more files, and then we'll need a way to persistently display this message actually. Now I'm thinking about it, because this is called a reframe. So I think I'll need to have a static bool here as well. Is error, I guess, is the good way to say it. The fun part of programming is when stuff you made intertwined perfectly with stuff you made. Creating new behaviors is so nice. Without much effort is so nice. Yep. I love myself I love me some intuitive APIs. Clean code that you say, I want to do this thing, and the code looks like you said you're doing that thing at first glance, and it's easy. This still sucks. It's one line, which is nice, but it's still using iterators, and iterators are the worst. C++ 20 is smart to move on to ranges, but this is C++ 17, so we don't have. We have ranges, but we don't have all the stuff that makes them work nice. Okay, so here's what we'll do. Whenever the selection is changed, I'll clear paths, then I will set is error to false. And then if there's a failure loading at any point, we'll say is error is true, and then if error is true, then we'll skip over the rest of the logic and just display this message, which I'll put down here somewhere after the selection is changed block. Yeah, like that. And then this would be where we add the GUI. All right, this is making sense. So is error, if is error. So is error equals true. Same deal here. Is error equals true. I also want to skip out of doing the rest of this code. So I guess it makes sense to just wrap this whole thing in an is error statement as well. If, oops, accidentally hit the wrong tab. All right, if is error is false, then we will do the rest of this, which is where we actually hit the file system for the rest of these. Okay, so if is error is false, then we have the first loop bool thing to hack our way out of having the first element in the range. Then we will, right, and this is where we were before I did all this. Now we can do the loading into the YAML buffer without worrying about losing the paths, because the paths are now an STD vector of strings, and we had copied from the buffer into paths using that line up above. Cool. All right, and if it's successful, then great. Else, we will say error opening file. I get. I'll worry about error messages later. I'm just going to say is error equals true. But you know what? I will keep this error, and I'll move a copy of it for the first load as well. But then we'll have, instead of displaying a message, we'll say is error equals true, and then the code down here will handle displaying the error message. Okay. Oh, except for I deleted the thing again, didn't I? Yeah. Oh no, I didn't. This is fine. So this EP error I'm going to paste up above here, where if the first file didn't load successfully, we will also print out its path. You know what, for that matter, we can do a per file error message here. So because if selection change is only called on the frame that you change your selection inside the content browser, these will not flood the console. It'll only flood it'll only appear in the console when you make a selection and it can't load a file. All right. Good. All right, so that can go. Awesome. So at this point, we've got a loop going through the second through nth selected files, and we have in the static variables here, we have the ones that we're going to pass into the field. So we do need to track. We do need to track whether the values are mixed. So we're going to need to do some more variables. I'm going to just do bools for each of these, named bools. It'll be a little wordy, but I think it'll get the point across. So type underscore is mixed. And then we'll say it equals false on all of them. Actually, this would be better if I just did a new line for each of them. A little cleaner. Yeah, this is a little clunky to read, but yeah. So now we got tracking for whether the field is mixed. When the selection changes, we will need to set all of these to true. Or to false, sorry. So that way we start out thinking that they're not mixed, and then if we find a difference, a discrepancy between the first file and any other, then we will set them to true, and then we can tell Gui to make a mixed field in the inspector. Cool, awesome. So down to where we were here, we'll say, let me copy these lines. We'll set type is mixed to oh, this gets actually more confusing. I was just thinking that I was thinking before when I was doing the copy from the vector of string views to the vector of strings. I was thinking that that's the only one I needed to make a copy of. I actually need to make multiple copies, don't I? Because the act of parsing requires that I have a variable to store them in. So, all right, new plan. I'm going to put paths back to being a string view. I will get rid of this insertion business and paths as views. Instead of doing paths as views, we will just do paths again. And then we'll say if this returns false, then we will the error. And then I'll just keep the string buffer, the YAML buffer. And so I'll make this static. This buffer will remain around until the next time we go to load. Because what will happen is we'll get to this point again, we'll call load text file, passing in the YAML buffer. It'll replace the contents with the first file of the next selection. And then we can continue using these variables like normal. But I'll need to have a local scoped version of that on the stack for every file that we parse through. Okay. Got a plan, sort of. So these will be the ones that we populate. These will be the variables that we populate with the second file through nth file, and we'll compare those against the ones that we have up above for mixed status. We're going to need some better names, though, to differentiate these. So the type, let's make this type field var. It's having a little bit of a hard time deducing what's the correct type field. I think that makes the most sense. Lol, can you use numbers? Type 2? Yeah, you can. But that's not helpful. I think I'll call one field and then I'll call one compare. I think that makes the most sense. Okay. Texture, type, yeah. Reduce, type from aspect ratio, yep. Yep, type field var. Yeah, all of these are unrelated, so cool. So type field var, paths, field var. I'll just do the renaming up here, and then I'll look for squiggles and correct these squiggles down below. Because I'm a little bit nervous about that refactor, because there are so many unconfirmed refactors in that list that I might have missed one. So I'm just gonna do this. And then these need to have field in them. Like that. There's still a red squiggle somewhere. Oh, up here. Paths. Field. Okay. I remember starting coding. One of the first things they teach is you have to have useful variable names. Me, no clue what I'm doing. Test 1, test 2, test 3. Yeah, I was a jerk on naming. Yeah, everybody goes through that. Usually it's. I think a lot of students like intuitively understand that they need to have good variable names, but they don't, because they like don't see the purpose of their assignment. They'll take the project that they're supposed to do, like implement this algorithm with this thing, and it's so abstract that that one variable name seems as good as any other. But yeah, that's a habit that is actually very easy to break, or at least it was for me. Is error equals false. Paths field dot clear. Well, I don't need to do dot clear on it anymore. Or do I? Hang on a minute. In the parse metadata, yeah, we do emplacement into that, so I need it to be clear before we move on. All right. Whew. Yep. A lot of little things. A lot of little things to worry about. All right. They're parsing file. They're opening file. Okay, so these are all good, well-named things now. Now I will have these stack variables, which will populate from files 2 through n. And I'll quickly give them a suffix as well. And these will be comparison. Maybe just compare. This is getting clunky to the point where I think I should just do like this. Some C++ folks are really, really against doing multiple variable declarations on the same line, and readability is a big reason why. Okay. Yeah, that's looking better. I'm gonna do the same thing up here, actually. Static int on each of these, and then projection, slicing, properties, and yeah, that's a lot easier to read. A lot of little static variables, but important ones. Okay, so we've got all of the declarations. We're ready to go. So I copied these down here not because I want to default initialize them, but I'm actually just going to set their value to be the result of a ternary operation. Actually, that might not be the best way to do this. Either way, I need the names. So we'll say if this is gonna suck because I have to do if statements for each of these basically, and they're all gonna look the same. It's just gonna fill up the lines of text in this file. Part of me wonders whether I should do this whole thing as a little macro, but well, we'll see how big it gets. So we'll say if type is mixed, and I'll copy those so I can bring them into the blocks. Oh, but it's actually not just if they're mixed, it's if they're not mixed, then we will do this check. Because if they're already mixed, if we already know that they're mixed, then we don't need to do a comparison anymore. Then we'll say this equals the compare value equaling the non-compare value. So we'll say this thing underscore compare equals the original field. Okay. It's a lot of little if statements. It's a little annoying. However, that's actually as simple as it gets for... That's as complicated as it gets for each of these, I think. With one exception, which we'll address in a minute. So because these are just one lines, I'm actually just going to go ahead and get rid of the braces on them and collapse these down a little bit. There's one example comparison here that is pretty bad, and that is the paths. This guy, the paths. Paths cannot simply be compared this way because they are vectors of string views, meaning that they point to different buffers. We actually have to do the comparison of these strings, and well, actually that might work. Let me look this up in the standard. So on CPP reference, I'm going to search for, I guess it'd be std vector. Because what I'm wondering about is on the equality comparison, whether it simply wraps the comparison of the inner types. Checks if the contents of LHS and RHS is equal. That is, they have the same number of elements, and each element compares equal with the element in the right-hand side at the same position. So we actually do a comparison check of the contents, like with an equality check, not just a data comparison. So actually that could work, because I think SD string does have a comparison against string view. Or actually, hang on a minute. They're string views all around, so I could do. Let me take a look at its comparison. Two views are equal if both the size are equal and each character in LHS has an equivalent character in... Okay, so it actually does a string comparison between them. Sweet, so that's great. I don't have to do a loop or something to make sure that the paths work correctly. Nice. So essentially we just parsed out all of the data from... Oh, we haven't done that part yet. So we got the stack variables here. We need to populate them. So I haven't done that part yet. That's the most important part. We need to parse texture metadata from the YAML buffer and passing in all of these variables. But yeah, once we have them parsed out using the parse function, then this equality comparison block will report or mark each field as mixed if it is, if it differs. Cool. I just need to copy all these variable names out. Oops. Last one, copy, and then we will paste and do the address of each. Oh, but I need the commas too. All right, and the last detail here is we need to do a check on this. Because if parse texture metadata returns false, that means that one of the files failed to open. And we would then do error opening file and mark the is error flag. Error opening file thing, file path. Yeah. File path being the iterated file path from selected files. Okay. Okay, and that's that. Yeah. It is Christmas. All right. So that's a fair amount of code. This whole thing, like we've encapsulated quite a lot of logic inside of the parse metadata function. Like all of this is just to parse out the data from the YAML file, and then we have to do that several times for however many files we have selected. So this is a function that this is a piece of logic that can actually take install for a little bit. However, the logic will only be invoked when you change the selection in the content view, so it should be probably okay. Probably won't be a huge drain on resources. It'll probably be as fast or faster than what we got here. If for some reason it's not, like when I go to shift select, that little pause probably is it just doing all of that logic that we just typed, which is that it's going through every single file and doing a comparison on every little thing. Actually, hang on. This is actually a case that I would handle way faster too, because I check the extensions and compare those before I even bother to compare the contents, which I know that'll go pretty quickly. But yeah, I don't know. We'll worry about performance if it becomes a problem. So I love the fact that we can see the pause with our slow eyesight. Yeah, Unity has got a lot of things going on under the hood, and I can't imagine everything that it's doing at the same time. So it's I shouldn't shit on Unity too much, but one of the big perks about having a custom engine, one of your own engines, is that you can eliminate anything that doesn't directly help you, and that's why I have such high hopes for this engine, for my engine, because it's like a general case purpose of a custom engine, and it gives you the perks of having a custom engine where you can unplug literally every little thing if you don't want to use it, or plug in any new thing that you want, and it'll be top efficiency. The only problem, like with efficiency in my engine, is the extensive use of the SDL, and that's not insignificant. The SDL can be in performance in a lot of cases, depending on how you use it, but yeah, the algorithms themselves and the way that the whole engine is structured is probably going to be very, very helpful. All right, so after doing all of that, all of this was just to get the values to put into the fields and to identify whether the fields should be mixed. Now that we've done all of that, this is where we actually do the IamGui fields. So we do IamGui. We'll need to add some stuff. I'll probably, we take a look at the style of the inspector in Unity. I'll probably have like a little banner on top of the inspector to indicate the files that you have selected, and I'll do that in the engine layer, so that way we're not having to or sorry, in the editor layer. So that way, when you're writing your own systems, you don't have to think about what's display. Like, you don't have to think about that part. You just have to think about the fields down below. So let's make a quick note of all the things we need to display. I'll copy out all of these names. From here, because they're in a tight block that I can see all at the same time. And then I will put them in comments so I can read them and copy and paste them if I need to. And then we'll just start at the first one. So I am GUI. Type is probably going to need to be a drop-down. I've never used an IAM GUI drop-down. We'll have to try that out. I guess right now what we should do is we should compile and make sure that I didn't break anything. When I go to select multiple files, and then we can, while we're in the program. Okay, so I'm able to select things without freezing. If I go to the textures, EB text, error opening one or more files, I probably don't have the right data inside that file. There's no error when I select the text files that I know work, even when I select multiples. So every time I change the selection, it should have reparsed these files. So that's a pretty fast process with these little EB text files. So I know that that's working. Let's take a look at the IAM GUI demo a little bit, because I've never done some of these widgets I'll need to do. So it's a combo box is what it's called. One linear array and function. I don't understand what the difference between these is, so let's take a look at the demo code and we will learn. But you know what, I've been going at this for 4 hours. I'm going to take a little bit of a break. We're very, very close to getting the inspector working. Honestly, the hardest part was just getting like managing all the data for an arbitrary number of files. But that part's over. It's just a matter of setting the data back out. Oh, that's going to be a thing. That's going to be a whole thing. Once we have the inspectors, we can modify the data that's in RAM that we stored as static variables. But I'll have to have like an apply button, and then that will have to write out the YAML data to the files. Ooh, that's going to be a whole thing. Given that is going to be a whole thing, maybe I should just stop now. Now, I'll take a quick break. I'll be back in like 10 minutes or something. And then when I come back, we'll at least get the fields to look correct. And so we can see what the fields look like when we select files down here. And then probably on Monday, the next time I do a live stream, we will actually get the data written out. Or I might just do that all offline. I'm not sure. I'll be back in like 10 minutes or something. Alrighty, where are we? Yes, back to where we were. So we've got all the data presumably deserialized out of all of the selected files, all of the selected texture files. We have identified whether they're mixed. We did a comparison between the first and all the other files. And we're ready to display. Oh, hang on. I see something I completely overlooked, and I'll have to fix it again. std string compare buffer. I overwrote the buffer containing the paths from the first case. So, all right, now it's ready to go. And down here, we're gonna do. Where did it go? Oh, down here. Down here, we're going to do the inspector for all the fields that we have just populated the data for. So we're going to need to do a little bit of research on this. It makes sense for type, min filter, mag filter, mipmap mode, and projection. These items, we'll do a quick little tab in. These items should be combo boxes. You know, what type is it? You click the drop down and say 1D, 2D, 3D, etc. And then min filter, mag filter, mipmap mode. There's only so many options. Same thing with projection. And then slice, columns, rows count. These should all be. Let me start putting some of these descriptions in there. So these should be combo boxes. The paths should be. Ooh, that's gonna be a little tricky. I guess it should be a reorderable list of selectables. I'm pretty sure there's a way for you to drag around selectables. I'm just not thinking of what it is right now. List boxes? Is that what I'm looking for? No, it's not. Not exactly, anyway. What I'm thinking of will be something like a list box, but it'll be like, well, it'll be just like a list of strings, basically. But we need to be able to reorder them, because in the case that you are providing multiple paths, you need to specify the order to know which element of the array it's going to be. Though there is one exception to this. Paths is going to be complicated. Paths, it's complicated because it's not just a reorder, not just a matter of reordering the list of strings. If we are using cube maps, we will probably want a better API to say this is the front, this is the left, right, and so on. So that way you're not just having to remember the order of cube maps and then get them in the right order that way. We probably want to be able to say, to make a GUI change when we're doing a cube map. So I guess paths is going to be conditional. Conditional on type. Texture type, I should say. And then slices, rows, and count. These will just be ints. Int drag sliders, probably. Actually, I don't see the value of making them drag sliders. Maybe I should just make them int fields. What do we have for that? Text, input. Yeah, I guess, yeah, this one that says input int, it's actually able to accept. Oh, okay, if you type in something that's not a number, then it'll get rid of it. But yeah, I don't know. Some int field is what we use for these. The is row major is going to be a checkbox. It's either on or off. Well, hang on. The underlying representation is on or off, but maybe we should have radio buttons for this instead. Because it'll be row major, column major. I think it would make sense to make those visible options. Okay. So that's what the types should be. Paths is complicated. At least its presentation is different. So let's say let's look at dependencies. Paths will depend on which type we have selected. So will slices. Because slices are not available in some texture types. If we take a look at the list again, I got this helpful little list of all the things you can do with one or multiple images. Slices are supported on texture arrays and 3D textures. And that's it. Slices on 1D, 2D texture arrays, and then 3D textures. Slices are not supported in QMap or whatever. So I'll say only if type equals 2D array, 3D, or 1D array. And then projection obviously is QMap only. And the types we were using were called split, cube, or rectangular. Wait, that's not right. Cube or cube array. That's what I was thinking of. Paths is kind of conditional. So we'll say there's got to be a demo in here that I can use. Listbox maybe. Using the simplified one-liner Listbox API, refer to list boxes section below for an explanation on how to use the more flexible and general begin listbox and listbox. Okay, let's look for list boxes. Maybe that's what I need. But it's Here, list boxes. Well, actually, maybe not, because it kind of works, but I can't drag around things inside. Is there a case that I can find real quick in Unity where I have this problem? You're not really seeing it. When it comes to textures in Unity, they actually don't do texture arrays like that. The closest they've got is cube maps. But cube maps are... Cube maps are still in one file. So it's still not... Yeah. How about Unreal? Is there something in here that... Well, it would have to be something inside of the entities list. I guess not. What I'm imagining is like a list of text fields that you can like have a handle on the edge and drag and drop around to reorder. There's got to be something like that. Maybe something under trees. Selectable nodes. Okay, that's something. Let me just do the good old-fashioned Google search. If I'm not able to find something that covers my use case immediately, then I'll just focus on the other things and not deal with path right now. Because as it is, we're only displaying the fields. We are not yet at the point where we're going to be serializing them back out. We're going to save that for Monday or for some offline work. I am Gui. Draggable selectables. Maybe? Little drag drop demo. That's not it. That's not what I'm interested in. Drag reordering. That's interesting. Okay, so somebody got a little gist showing some ImGui code. Let me fix my mic. It's dripping a little bit. There we go. It's a little bit better. Yeah. So what have we got? Is mouse dragging GUI, drag it at resource copy. So I guess this is a whole thing. Like you have to implement it yourself. Okay, it kind of looks like, this is a more classic example. It kind of looks like this is something that doesn't exist. I want something like what we're seeing in this GIF, where you can drag and drop things around, but I want it to be, I want the things that you drag and drop to be text fields. So that's actually going to be a little bit harder to pull off, it looks like. So I'm going to go ahead and skip over the paths section for now. For now, we will just focus on the type, all the combo boxes, the integer boxes, and the projection boxes. Yeah. So types. We'll do I'm Gui combo probably. The label here is going to be type. I'll say texture type. That's actually literally what it's called in Unity. All right, seems like a good UX name. Current item. So we present an integer, and then we present a list of items separated by zeros. Okay. So what else do we got? So separated by zeros, and then we have an array of constant R's. That's probably a little bit nicer. Maybe not. Int items count. Oh, for the size of the array. Int pop up max height in items. Okay, so I think this will be the one that we use. We're going to have to index into the list. I'll just provide an int for the sake of example. And we'll construct the combo list now. So let me do some rearranging. Okay, so we have 1D, 2D, 3D, so on and so forth. I'm just going to copy the list, paste it in here. And then, oh, it's word wrapping. When did word wrapping become enabled? Alt-Z, I accidentally enabled word wrapping. All right. So that's the list. We need to make these zero separated. Oh, that's awkward. I wanted to separate like this, but the 2 is being combined with the null character, the null literal. I guess I have to, if I provide enough zeros, then it'll cap out. So I can do it like this. So 1D, 2D, 3D, and then cube, 1D array, 2D array, cube array. Okay, so this is the full list. UX wise, I might want to group the 1D and 2D together. I'll just see how it looks, and we'll go from there. The selection that we've got is an enum class. That's this type field. The texture type field has cube array. It has an order to it. So what we could do is we could just take and cast this to an int and then provide its address to this. That'd be one way to do it. Though obviously we can't have a none type, so yeah. So what we'll do then is we'll mimic the order of the enum. And then we will just cast the variable to an integer and subtract 1, and that will be the index into the draw box. So we'll say int texture type. We'll say type field as int equals std dynamic. What am I saying? Dynamic cast. Now we'll do a C style cast to int from type field, and then we'll -1. Okay. So now we have it, and we can pass it into the combo box. All well and good. It will receive the value that we change it to if and when we change it. I don't know whether mixed fields are supported for combo boxes yet. I don't think they are. I think they're only supported for the things that we added support for, as well as checkboxes. So for now, we'll just do we'll have display the first one. Then there's paths. We're going to skip paths for the moment. And we've got min and mag filter as well. So min and mag filter. There's an enum in graphics.h. Actually, textures.h. For texture filters. Right now it's literally just nearest and linear. These will be expandable in the future. Because we'll have anisotropic filtering at least. To add to this list, the only reason why it's not already here is because it's an OpenGL extension and I haven't bothered to add it yet. So we'll actually have to do something very similar to what we did here. We cast it to an int, and then get it to the point where get it so that it lines up with the actual enum, and then pass it into the combo box. So this will be, instead of type field is int, this will be min filter field is int, and then we'll have mag filter as field is int, and then map mode field is int. And we'll do similar casts. Is that right? Yeah, it is. Okay, and then Texture filters doesn't have a none in it, so we don't do the subtraction on these. These are just directly aligned. Mipmap mode has a none, and then it has a nearest and linear, except for none is a valid value in this case, so we don't do a subtraction. It's only the type field where we remove the option none. Actually, now that we've done a refactor, it's possible that we don't even need the none variable inside of the type field. So I don't know. We may want to change that at some point. But now we pass in the variables, the new variables into the fields, and then we need to change what these represent. So in the case of min and mag filter, these are actually identical. It'll be the nearest and linear. Interestingly, in this example, they did null terminate. I don't see why I would have to do that because it's a string literal. It's going to be null terminated, but I'll add a null termination if there's a problem. And then the mipmap mode field. We have none. We have nearest and linear, I believe. Nearest and linear. And then those are the valid options. Okay, and just for the sake of confirming that these fields look and work correct, I'm going to make them static. Oh, but then the problem is that I have to assign them. Let me think about that. Yeah, so on these, I'm gonna copy them real quick and then do static declarations up above. And then we can't make them static. We have to take the values that we get assigned out and set them back into the enum type. So what we'll have to do is we'll have to do the original field variable. I'll assign it back out a cast of the original value. So that would be these. And then in the case of the top one, we have to add a 1 to it. Okay, and so let's get the types in there. That'll be Gui. Wait, not Gui. Type field. So this will be texture type. Does that work without light? Okay, it does. These will be texture filter, and then this will be mipmap mode. Okay. And the point of doing this reassignment is so that way that when we make a change, it's persistent each frame, but when we change the selection, it will also update. Okay. I think this is good enough to start. Let me run it. And we'll see what it does. We won't have any mixed fields here because I may have to implement that myself inside of Gui, the way that we did for the text and the drag floats. But if I'm right, okay. So if we select a texture, oh, the names of the things are not correct. I didn't rename the fields. Okay, so this should be magnification filter. Magnification filter. And of course, these strings are used to generate unique IDs, so they won't function correctly until they have different names. And this will be mip map mode. Okay, let's try that out. Okay, textures. Okay. So I think we're getting somewhere. Selecting the texture 1 EP text, we have 2D nearest none. Texture 2 is the same, texture 3 is the same. Let's make an edit to this one. I'm going to change the... Which one is this? I think this is Madeline. I forget. We'll change the mag filter to linear and the map mode to linear as well. We've saved it, and now when I go to select it, it says, well, the magnification filter is saying linear. The bitmap mode has still got a problem. There was an error parsing the file. Parsing the file is simple text.eptext, that's different. So it looks like magnification filter is reading fine. Bitmap mode is not. And I wonder why. So let's go to the parse metadata function. And let's look for the bitmap mode code. I'm going to set a breakpoint on it, so whenever we go to parse a file and we're trying to interpret its bitmap mode, we should be able to see it. Okay, so here we are. This is in the middle of parsing this file, text1.eptext, reading the bitmap mode section. So bitmap mode, where's the... So here's the node. I can't directly read its value. I have to... Oh, here it is, node. Actually, maybe I can. Maybe I can read its value. Is there a... I guess not. So what we'll do is we'll step into the conversion function. Here we go. String to bitmap mode. And this is the string we got out. str, and it's optimized away. That's great. I don't know what it is with C4. Maybe C4 is optimizing even on debug builds. Maybe that's the problem. I'll have to look at its CMake file. Okay, interestingly... Oh, okay. This is probably just a bug that I've never had to worry about before. I have a typo. I have it setting the bitmap mode to none when it should be linear. Okay, I thought there was a problem for a minute. I guess not. So this should be easy to fix. Let me confirm that the parsing is looking correct in the filter as well. So nearest gives you nearest, linear gives you linear, and we have nearest in the case of a failure. That should probably be none or something if there's a failure, but whatever. All right, let's try that again. That actually probably means that we're A-okay and ready to move on. Okay, so texture 3 says nearest, nearest, none. Same thing for text 2. Text 1 says nearest, linear, linear. perfect. So it seems to be reading the file correctly. So I could do, for the minification filter, I could do linear, and then I can do nearest for the mag, and then map mode I could set to nearest as well. And I'll save that, and then in the inspector, it's reflecting that 2D linear nearest. Now I'm also going to do something a little sus. I'm going to change the type to cubed, even though I don't have cube support type yet, and that's basically just to confirm that the type appears in the list, and it does. So we've got 1D, 2D cube, 1D array, 2D array, cube array. There's a whole bunch of extra things inside of this list. Oh, these lists are sharing elements. There's something wrong with the lists. I think I have to null terminate those strings. I think that's the problem. I think it's making me when I have the combo boxes down here. The demo indicated that you needed to have a null terminated character at the end of the string. And I thought that was a little weird because it's already null terminated. It's a C string anyway. You don't normally have to do this at the end of a string literal, but maybe it's a problem here. Okay, that seems to be better. So now minification and magnification filters just say nearest and linear, and I can change those if I want. Map mode now gives me nearest and linear as well. Map mode, hang on a minute. It actually gives me none nearest and linear, so it's slightly different. But yeah, and now I've got the ability to see what they're set to in each texture file and make changes, quote unquote, inside of the inspector. However, now the problem is that these changes need to be serialized back out. So we'll need to have like an apply button, and we'll need to have the code that will actually take and write the changes to each of the selected files. And that's going to be a little bit trickier. But yeah, this is good progress. We also have to worry about displaying the fields as mixed. And ordinarily that would be an easy thing to do, except for DRI and Gui hasn't implemented it yet, so we have to implement it ourselves. And that could take some time as well. But yeah, I think for now we're actually doing all right. I think this is a good place to stop. One thing though that I'm noticing is that the texture type, I kept the underscores inside of the names, and those could be spaces. I don't need them to be without spaces. But yeah, huge amount of work done. Yeah, now we can select 1D array, 2D array, cube array, and so on and so forth. I may want to order these in like a different way, because like very rarely will you be using 1D or 3D textures. Almost always it'll be 2D textures or cube arrays in the case of environments and skyboxes. Though the 2D array might be fairly common too for the sake of sprite sheets. I'm on the fence about that. But yeah, I think this is a good place to call it. Thanks for popping in if you did. I will stream again back on Monday. I think I may continue to play with this offline though, and see if I can't make the inspector actually contain all the fields that I want it to. See you later.